think we'll get started now. For anyone who doesn't know, my name is Wendy Erminger, and I'm in the Community Planning Division. We've been working here for several decades. And before that, a long time ago, I was at University of California at Santa Barbara, and I majored in environmental studies, which, after the 1969 oil spill in Santa Barbara, a lot of environmental interest was generated from that, and it spawned a lot of programs for people who, like me, were interested in, saving the environment. Back then, and we can have a conversation about this at some other time, we knew about this stuff. And I didn't do that too much about it in the last 40 years. I mean, we're getting there. There are people like Dave who are working in this field, but there's a lot more to do. So I hope after this presentation today, you might come away with some ideas. You might be inspired to look into what he's talking about in greater depth. But, there certainly is a lot to do, a lot of work to do in resiliency and climate change and how we respond to the impacts of climate change. So with that, I want to introduce Dave Jones. So Dave Jones, if he's a familiar face to you, it's because he was on TV for about a decade. Several years ago, he was the meteorologist for NBC4 and started the first in the country, first website for meteorology in the country. And maybe his spirit of innovation and entrepreneurship followed him. After he left NBC, he founded and is CEO of Storm Center.
Yes,
Communications. And he's been a leader in this innovative field of dealing with climate change for a number of years now. So his company is Storm Center. Isn't it up by UMBC, up in the technology?
On the south campus of UMBC.
Of UMBC. Got started from a small business, like an incubator, not incubator, but innovation.
In my basement.
Innovation. Well, there you go. That's an entrepreneur.
About as small as you can get.
I think Apple got started there too. It was in the garage, right?
I think so.
So he can go. He's going to give us a presentation now on the various platforms that can be used to communicate and help us with the dealing with the impacts of climate change and thus resiliency. So with that, Dave Jones,
Great.
welcome.
Thank you.
There you go. Well, thanks very much, Wendy. I appreciate the introduction, and good morning, everybody. I hope that we can have a nice informal conversation. If you feel like you have a question at any time, just raise your hand, because that's how I like to roll. Is just if you have a question, you think about something, I want you to ask it as soon as it comes to your mind. And I'm going to talk about a couple of different things this morning. First, I just want to talk a little bit about why we should care about some of the things that Wendy talked about. The reason that I started Storm Center Communications back in 2001, I left NBC in 2000, started Storm Center in 2001, was to focus on two things. One was communications. I have a decade of experience working at NBC, but before that I used to work for a weather graphics company that designed and sold weather graphic systems to TV stations around the country. So my job was to not only help to design user interfaces, but to actually go and train broadcast meteorologists at their TV stations around the country how to use computers in forecasting and how to create graphics so they can communicate on the air effectively to their viewers. So what I do right now on the communication side is that we do video production, we tell stories of science and deliver science to the community so they can understand it better. And we also put together annual weather and climate summits for broadcast meteorologists. So I help organize this summit. It's called the Glenn Gerberg Weather and Climate Summit. We have it every year. It's been the last 33 years in a mountain ski resort, whether it was Steamboat, Colorado, or Breckenridge, or Aspen. This year we're working on doing something a little bit different. We're looking at taking broadcast meteorologists into the heart of climate change so they can experience the impacts that the tropics have had. So in order to get that, you get them to attend. You want to have it in a decent location. So we're working on having it in on a cruise ship and taking people to various islands that were impacted by hurricanes so we can then do stories and communicate back live to their audience. So that's what we do on the communication side. We also do technology innovation. And the innovation that I'm going to talk to you about today is called GeoCollaborate. There's been a long, decades-long problem with how do you access and share data across platforms so you can keep people on the same map at the same time. And we went through this process through a federal government contract, which I'll talk about shortly. But essentially, we're working to improve data access, sharing, and collaboration, and to improve situational awareness for better decision making. So when you think about that, it's not just for responding to extreme weather events, it's also for planning future communities. It's also planning for the impacts of climate, perhaps sea level rise and things like that. So all sorts of things can be done more streamlined when you can connect people on disparate platforms and show them what you're talking about. So I just want to step back for a little bit and just talk about the Earth real quick, because it's the only one we have, and it's beautiful from space. This is a satellite picture from the GOES satellite that NOAA has launched, and this satellite picture gets updated every 15 minutes. So there's a great look that we have as meteorologists, as scientists, to observe the Earth and observe the changes that are happening. And while you can see the clouds around the Earth, you can also use different channels, different wavelengths that are on these satellites to look at different things, like water vapor, moisture, things like that, that really help us forecast. And we have a lot of impacts around the country. This is one from the California wildfires not too long ago. Communities now using these signs to tell everybody there's flash flood watches, trying to get the impact to people so they can really plan for what's going on. And we're seeing a lot more of these popping up because things like community sirens, things like getting warnings to mobile apps and things like that are good, but they're not reaching everybody. We all are real familiar with the flooding that happened in Ellicott City over the last couple of years. I'm working with some folks there to see how we can improve the warning capability into the businesses in Ellicott City, right down on Main Street. So I want to talk a little bit about why should we care? I mean, a lot of you hear about CO2 and things like that going up into the atmosphere. I want to step back a little bit and just tell you why this is important, that leads eventually into planning. We should care about this because these CO2 gases that get put up in the atmosphere act sort of as a blanket, an insulator, if you will, around the atmosphere. And so when the sun shines its energy down on the Earth every day, some gets absorbed by the land, some gets reflected by clouds. But then the energy that gets absorbed by the land wants to escape as well, so it radiates back up. Well, the more CO2 that we have in the atmosphere, you can think of it as putting another blanket on the atmosphere, and then another blanket, and then another one, so that heat doesn't escape. Some of it does, less and less is escaping. And this is a trace of what the CO2 levels have been over since, let's see, this is 1800, 1750, so 1700. You can see it's been pretty steady until about the Industrial Revolution, where things have started to tick up, and now you can see how fast it's going up. This is 2000 right here, so it's really getting a trend that's very concerning. And just 2 weekends ago, we hit 415 parts per million of CO2 in the atmosphere. That's significant because we haven't had a number of 400 for a very long time. And so this was just on May 11th, an article that was 84 degrees near the Arctic Ocean this weekend as we hit this 415 degree CO2 level. Now when you think about CO2 levels, it's not totally like a 415 doesn't mean we're going to be in the 80s for the rest of our lifetime, right? We have weather. Weather changes. But over the long term, you see long-term trends, and you'll see this concentration of CO2 continues to go up. And then this is a trace from the NOAA Environmental Science Research Lab. They're monitoring carbon dioxide at 4 different places: Barrow, Alaska, Mauna Loa, Samoa, and the South Pole. And you see all these lines going up and down, but they're really following this trend of going up pretty significantly. What you see here going up and down is actually the Earth breathing. So in the fall, when the leaves fall off the trees, the trees do not let out any more oxygen, O2, into the atmosphere. So you can see the levels going down, but when going up, because the CO2 levels, more CO2 is being released. But when the springtime happens and the leaves come out and the plants are absorbing a lot of CO2, then you see the amount goes down. So everywhere you see down here is the springtime, and everywhere you see up above is the fall. So you can really see the Earth breathing, inhaling and exhaling through the vegetation, which is really important. Here's the location in Barrow where this particular sensor is recording its information. And so we can go back even further in the record. We can go back through ice cores where scientists go to Greenland and they dig through ice cores or drill through ice cores. And it's really amazing. Every time it snows in the history of the Earth, a piece of the atmosphere and the oxygen and CO2 levels are captured in that ice, and then it gets compressed in the glaciers of Greenland and those locations. So when scientists drill down, they can look at it. It's like a storyboard. They cut that long tube of ice up, and they can see the atmospheric composition way back in these times. And all the way back to the year 1000, you can see the CO2 levels haven't really varied much between 275 and 280 parts per million. And then when we get over towards the industrial age, it really shoots up. Why should we really care about that? And here's the level for 2019 that's up even higher. So why should we care? So this is one other graphic going back 800,000 years. You say, well, how can we tell 800,000 years back? Well, it's the same way. It's the same way you can tell in those ice cores. We followed scientists drilling in Greenland. It's what's called the Neem ice core in the summit of Greenland. He was drilling down, and we were with him when he hit bedrock. And that ice was 250,000 years old. And there are other places where it goes way back. And then you have trees and carbon dating, things like that go back much, much further. But you can see this variation, right? Yes, you go up and down, you have natural variation in the carbon dioxide cycle, but then you get to the industrial age, and we're up here. So this is just the science that I'm showing you, and you really can't dispute it because they're measurements of the concentration in carbon dioxide. And then, so this is back 800,000 years, and there we are again here with 2019's levels, so we're going up at an even faster rate. Okay, so why do we care about all this stuff? Because we live on a water planet. 90% of the extra heat that's absorbed by the atmosphere and stays in the atmosphere goes into the ocean. The ocean is a huge sink for carbon dioxide. And the atmosphere, our weather, responds to the surface ocean, right? So if we had a warmer ocean, we have more potential energy in the ocean for storms to develop, specifically hurricanes, tropical storms, cyclones that come together. And so this is a graph of the actual ocean heat content. How much heat does the ocean really hold? And this light blue is from 0 to 700 meters. So the surface down 700 meters. And this is how that's growing in temperature. This is from 700 to 2,000 meters. Takes a lot longer to heat that, right? You fill a swimming pool up, takes a long time for that thing to warm up unless you have a heater. Just by the sun. So down even deeper, but we're seeing indications of it warming there. And then even land, ice, and atmosphere. This is the whole Earth showing the rising temperatures. So So oceans play a big role in what's happening with our temperatures and with climate change in general. So, whoops, let me go back here. So in September of 2018, there was so much heat content in the ocean, we actually had 10 tropical storms that were active around the globe at one time. So we're seeing some abnormal warming of the Atlantic out here, so we're seeing more systems seem to be developing there. And then, of course, the typhoons. There have been a number of super typhoons out towards the Philippines and those areas. And then Honolulu and Hawaii has been pretty impacted over the last 2 hurricane seasons, 3 or 4 times. So this is just a animation of real data from NASA, and I'm hoping I can make this go here. Just by clicking that, I think. Maybe. Oops. Let me just. Is there? Oh, there's. Oh, gotcha. Right. You're right. Sorry. Okay. So this is from the 1800s into 1908, 10, 11, 12. It's just generally speaking, this is an animation from NASA looking at global temperatures. And you'll be able to see that it's just generally warming up. And when it gets to the last decade, it really warms up. And so while we're seeing the CO2 levels go up in the atmosphere, the temperatures of the Earth are kind of lagging behind a little bit, right? It's a big system. It's a big system that has to respond to the input of this heat. So, but what we're seeing now is the last 4 were almost more than 1 degree Celsius above the global mean temperature. So we're seeing the temperature starting to catch up to a trend like CO2 levels. It's lagging behind, but we're starting to see that increase. So whenever you have temperatures increase, you have impacts at the surface down below, which controls drought, impacts on vegetation and all that sort of stuff. So NASA and NOAA have some programs where they're working very closely together to monitor not only CO2 levels, but global temperatures through satellite records and all that stuff. So that's sort of just a brief little animation of what's happening from a global perspective. And you know, we can really get into some math and graphs and stuff like that, but what I do want to do is make this a little bit more clear. I'll make this a little bit more clear because of just one thing I want to point out here. This is from Dr. Jim White at the University of Colorado, and he made his presentation for a number of years, actually. This is sea level change in meters, and this is a global mean temperature in Celsius. We're right here in the middle. If you use this dot in the middle for us, remember I showed you that CO2 levels were 415. So the last time we had 400 parts per million with CO2 was 3 million years ago. 3 million years ago in the Pliocene period. So if we look at that dot and we just do a little simple exercise with graphing and draw that line straight over to the sea levels, we find that 3 million years ago, sea levels were 24 meters higher than they are today when we were at 400 parts per million in CO2. Okay? So what that means is not just 24 meters, but that's 78 feet. So we're headed in a direction where we're seeing melting at an increased rate. Okay? We're not going to see a 78-foot sea level rise in the next few years, decades. You know, it'll probably be well past 2100. But the thing is, it's coming. And so that's what you really need to start thinking about when you start to plan certain things. When you want to plan infrastructure, you have to plan for 50 years ahead, 100 years ahead. What will be the impacts? So knowing what's happening with the atmosphere and carbon dioxide levels and things like sea level rise should probably influence how you're designing the communities of the future. Yes?
So, with that, going back to that graph, so is the CO2 levels above 400, is that a causal factor for the oceans, the rise of the, sea level rise? Is that causal?
So what's happening is, and that's a great question, is the CO2 levels, are they causing the sea level rise? So the more CO2 we have in the atmosphere, the more steep trend we're seeing in rise of global temperatures, right? I mean, let's say like Alaska in the last year to 2 years was 8 degrees above average for their winter temperatures. 8 degrees, that's pretty significant. And so when you have that rise in temperatures, then you start to have the melting of the glaciers that are over land. So in Greenland, for example, the amount of ice that's included, that's contained within Greenland could result in about a 24 to 27 foot sea level rise. If all of Greenland melted, global sea levels would go up by 24 to 27 feet. Now, that's not going to happen anytime soon, and there are areas in Greenland where some of that water would just turn into a huge lakes and maybe not get out to the ocean. But there's that much sea level rise contained in the ice. So when you have a rise in CO2 levels, you have a rise in global temperatures, and that rise in global temperatures is going to melt ice. It's very simple. It's not complicated at all. But what is complicated is at what rate is that happening, and when will we see those impacts and that sea level rise go up at a continuous rate. So okay. So we do live on this water planet. It takes time to heat up the water. We're seeing an increase in tropical storm activity, not necessarily the number of storms, but we're seeing the storms that develop get more intense. So you have more potential energy in the oceans that these storms can feed on. Okay? Hurricane Maria, Hurricane Irma, Hurricane Florence, Hurricane Michael. These storms, Michael was just upgraded, as you probably know, to a Category 5 hurricane hitting Florida last October. So it's the first Category 4 or 5 storm that's ever hit that part of Florida. And these impacts come after the causes by about 50 years or more. Okay, so we're seeing the CO2 levels go up. We're starting to see the system start to react. And then that's why some people talk about a point of no return, where when you pass that point, temperatures are just going to go up, and they're going to go up. We don't know what that point is right now, but we're seeing the trend and rise in temperatures. So this is an intergenerational issue, right? Our kids have to care about this. Our kids' kids have to care about this, and they're the ones that are going to be impacted by some of these major changes that are happening. So here's just an example. You might say that, well, this isn't really happening today, but it is. Go to Miami. And this is a perfectly sunny day. This is tidal flooding in downtown Miami. Miami has installed, I think it's 3 or 4 $300 million pumps to pump out the water from their sewer system and when it floods like this, and they couldn't keep up with it just a couple weeks ago. So if they have just tidal flooding and then they have a big thunderstorm that's dumping 3-4 inches of rain on them, that just exacerbates that problem big time. And this is seawater. This isn't fresh water. So salt water has, as you know, a much more detrimental impact on infrastructure. So the warmer ocean also expands, right? When you heat something, it expands, right? You design that into bridges and all that sort of stuff. And when you cool it, it contracts. So when the ocean heats, it also has thermal expansion to it. So you gain additional volume from water when it heats up. And so here's just an example of some impacts around the world of a 13-meter rise. This is 43 foot feet rise, impacting millions and millions of people in India, Bangladesh, Washington, D.C. These areas would be inundated. Prince George's County is in here as well. So, well, it's a little bit further over there. But the Potomac would take on a new area. This is a 13-meter rise in what the southeast would look like. So we're talking about New Orleans, Lake Charles, Baytown, Galveston, Pensacola, all around the lower half of. Look at this. This is the Gold Coast right here, with several $1 trillion worth of real estate and all that sort of stuff that's impacted. And it goes up the coast, and water. Excuse me. Water is what really kills the most people when storms come and impact the land. So it's not when a hurricane hits, it's not really the wind of the hurricane, but it's the surge and then the resulting floodwaters. People tend to think that their vehicles can handle water, and they'll drive into puddles, not knowing that the road might be gone under that puddle or whatever. So we see a storm surge. It's a 49% results in deaths, and rain 27% here. And so here's another graphic just to show you how you can equate how much moisture is held in the atmosphere. I mean, how many of you have noticed? Yes?
So, I'm sorry, I had
Sure.
a question about increased storm, rainfall events, right, where the rainfall, I guess, ends up being at larger quantities, and then also with like the rising of sea levels. So I was thinking about like some communities in our neighborhood or in this county, like North Brentwood. I mean, so I guess what are like the cumulative impacts of if I live next to a river, and then the river might actually be rising as a result of sea level changes, but then we might also then be getting additional rainstorms that are also heavier rainstorms.
Yes.
How do those two things then, I guess, happen in conjunction with each other?
Well, that's a great question. So the rising sea level will impact the infrastructure because you have your bulkheads and all that sort of stuff that's holding back water. So if you have sea levels that are rising, you need to take a look at where those bulkheads are and the layers that the levels that they are. Whether those homes along that river are elevated, whether they should be elevated, should new codes be enforced, or put into practice to make sure new construction is elevated. But then when you have heavy rain, that impacts a whole nother piece of infrastructure. It's your stormwater management. So not many stormwater management systems, I would say probably less than 1% in the country, are designed to handle the increased rainfall rates that we're seeing. So we see overflows, we see manholes blowing out, and all that stuff because it just can't handle that pressure. So it's not going to get any better, unfortunately. And that's what this graph sort of shows. For every 1 degree increase in temperature in the atmosphere can hold 4% more water in the atmosphere. So we're dealing right now with situations where we have 5 to 7% more water in the atmosphere, which means when a thunderstorm forms and it rains harder, heavier. And we're seeing that all over the country. Rainfall is becoming more intense, right? 8 inches of rain in Ellicott City over a 5-hour period. No system is going to be able to handle that, not even the new plans that they're going to put into place with the tunnel and all that sort of stuff. It's just going to be overwhelming. And they're, in Ellicott City, they're planning right now to put in, I think, maybe like 40 to 60,000 acre feet of capacity above Ellicott City, and stormwater retaining areas. But it was 300,000 that fell in that storm. So, when you have that kind of storm, that kind of capacity is not going to hold back anything. And so, so here in this next one, you can see more downpours in the U.S. Look at the trend line. It's going up where we're just seeing a larger number of downpours across the country. Let me go back to this one here. Here's one for Baltimore. Baltimore, we're seeing the increase. Yes?
How effective do you think like cap and trade programs are on really stopping climate change?
So
And I
you
guess-
mean like putting a carbon tax?
Yeah.
I think, you know, to me, we have to lower the amount of carbon dioxide going into the atmosphere. Whatever ideas are out there should be considered. But usually when you equate putting carbon in the atmosphere with more money somebody's going to have to pay, they'll be more diligent about how much carbon they put up into the atmosphere. But I will say that with the amount of carbon dioxide that's in the atmosphere right now, because we really haven't done anything, we've actually increased our carbon dioxide. Carbon dioxide will last in the atmosphere for 100 to 125 years. So the trend that we're on. We're on, that train has left the station. So if we stopped all carbon dioxide emissions into the atmosphere today, like that, it would take 150 years for the Earth to respond. So the longer we take, the more damage we're doing to our future kids, you know, and communities. Yes.
When you were showing the graph before that showed 3 million years ago and our parts per million was really high, what was the phenomenon that caused that? Because obviously it wasn't people.
No, it's volcanoes. There were things like that. Different parts of fires across the globe. I mean, you know, it was well before humans and all that sort of stuff. So there were all sort of carbon releases into the atmosphere because of that. And we can tell the difference because when you carbon date something back that long ago, you see trace chemicals in there. And the trace chemicals that we're seeing in today's CO2 are all industrial. Pretty much all industrial. I mean, you know, some people could say, hey, a volcano could, you know, blow up and do this and that. We can now put fingerprints on the type of carbon dioxide molecules that are in the atmosphere today. So we see this trend from, look at this, to the downpours, daily deluges in Baltimore have gone from back in 1950 being about 2.7 inches to now 3.5 inches. So we're seeing, we have the data. We're seeing the amount of rain increasing as we go forward in time. So I just want to show you some answers that people have given to researchers and folks at the Weather Service when they come in and talk to them about disasters that have happened and floods. These are some responses. They say, my house is elevated. I thought we would be just fine. So this was after their house was elevated 6 feet and Hurricane Michael pushed in a 14-foot storm surge. House was gone. It's never flooded here before. These are probably things that you hear yourself from residents in Prince George's County. It's never done it before. Why should it happen again? We're in a different world. The atmosphere holds a lot more moisture. Our carbon dioxide levels keep going up. These storms, they always turn. They never hit us. I'm going to stay here and I'm not going to evacuate. They always turn. I thought these floods come once in 100 years. It would be really nice coming out of this meeting if everybody stopped talking about a 100-year and a 500-year storm, because they don't mean anything. It does not mean that this 1 in 100-year storm is not going to happen again for 100 years. We're in a changing climate and an energized environment where 1 in 100-year storms could come every year. And that's what they saw in Ellicott City, right? They were calling them 1 in 500-year storms, and they had 2 of them in 18 months. So we have to get that language out of people's conversations. It's just a tropical storm. People tend not to evacuate if they see it's a tropical storm, but a tropical storm can drop more water than a hurricane because of the dynamics in the storm and the slow movement. I live 100 miles from the coast. I didn't expect this. I think this can really be helped by counties having more outreach, having more communication activities to talk to their residents about, look, if a storm is going to hit Ocean City and it's it's moving west, it's going to hit you too. And it's probably going to be just as bad because we don't have a lot of mountains that are going to knock anything down between the coastline and our area here. This didn't happen last time. I got hit. I was in Hurricane Camille in 1969, somebody might say, and they were on the fringe of the hurricane. And that was the worst hurricane in history, but they were on the fringe of that worst hurricane in history. And then Hurricane Michael comes, and Hurricane Michael hits them in Mexico Beach and gives them a 15, 16-foot storm surge. So people don't really understand weather and its impacts. And then it was nothing when I looked a few days ago. People tend to think if they look at the weather forecast today for the weekend, it's not going to change. And we know it changes every day. When I was on the air Channel 4, I'll never forget this one call. I got off the air from doing the weather. I got a call from a lady, and the lady said, "Dave, can you tell my daughter's getting married in 6 months, and I need to know if I should rent a tent, you know, and could you tell me what weather you have scheduled?" So this is a great one, you know. I mean, it's a doozy, you know. So people think that when they see a 7-day forecast on TV, that's the way it's going to be for the next 7 days, and then they put it in their mind. Oh, he said sunny on Saturday, and then they go about their plans, and then Saturday it's raining, and they're like, they said it was going to be sunny. No, the forecast actually did change, and 3 days ahead of time it changed to rain. You just didn't watch. You know. So why all this science stuff? Why am I talking about this when I came to talk about data sharing and collaboration? Because as a scientist, scientists know what's happening. We know what's happening in the atmosphere. No matter what people say about it being, you know, this or that or whatever, we know the science, and the science is showing us this. What we don't know is how fast that trend is going to continue and steepen. How fast those sea levels are going to rise. Everybody wants a number. I was down for 4 or 5 meetings in a row down in Norfolk and Hampton Roads with Senator Kaine and others that were talking about, we want a number. What do we have to plan for 2 years from now, 5 years from now? The science is just not there. I mean, just last year, NASA discovered an underground lake in Greenland they never knew about, where the ice was already melting and the water's making its way towards the coastline. So once that fracture in the ice opens, we'll have another 1 trillion gallons of water that we didn't plan on, you know, going into the ocean. So it's really, there are a lot of unknowns. We know what's coming with increased certainty. Scientists will always put a level of uncertainty into their statements because science is not exact. But what we can say with confidence is CO2 levels aren't going down, and sea levels aren't going to reverse and start going back. So we must plan for heightened risk. And ignoring science is throwing risk out the window. So there was an article that was just published on April 5th, and this usually gets investors' attention. Get ahead of these risks. BlackRock issues a climate risk warning to investors. They say the trend of rising average temperatures is boosting the frequency at which extreme weather events occur, as well as their intensity. These changes are affecting our economy today, and investors who are not thinking about climate-related risks or who view them as issues far off in the future may need to recalibrate their expectations. So it basically means we have to get our heads out of the clouds and start thinking realistically about the changes that are coming. It's not easy. You might have projects that you're planning right now, right, for the next 10, 15, 20, 30 years. Have you considered the impacts of a changing climate, of heavier rain, of increased number of storms? So this is all very, very important. And the report finds, Electricity, utilities, commercial real estate, municipal bonds, they're all consistently underpricing physical climate change risks to their business. So what they also said was they've urged investors around the world to urgently rethink their assessment of climate risk after research found key industries are vastly underestimating the amount of economic dangers posed by the low carbon transition, right? A low carbon transition. We're not moving to a low carbon transition fast. It's because of the low carbon, the rate at which we're changing over to it. So look at this. It says, looking out to 2080, this is their forecast, 58% of U.S. cities and metropolitan areas will likely see GDP losses of up to 1% or more due to climate change. This is out there. You have to include this in your planning and your thought processes. This is another thing that just came up. This is from May 2018 to April 2019. Look at this. See this dark green area right in the mid-Atlantic and out towards Tennessee, Kentucky? May 18th through April 19th is the wettest 12-month stretch on record for the U.S. We know there's more moisture in the atmosphere. I showed you there's more moisture in the atmosphere. I showed you we have heavier downpours. And now this is what was observed, the wettest 12-month stretch on record for the U.S. So Deke Arndt from the National Center for Environmental Information down in Asheville, a warmer world turns up the hydrology dial. When we are sent the bill for climate change, it comes in the context and form of our water. That's one of the most important things you can start to plan for, and that is the water and stormwater systems and vulnerabilities along the coast. This is just a little video. We produced a video for NOAA. This is the end of that video showing Ellicott City. The video itself was on JPSS, the Joint Polar Satellite System that NOAA has launched, and we were telling the stories about that and how it can help certain forecasting and observations.
Howard County 911. There are two people on Harbor River. We're drowning here, Daddy. I don't want to drown in my store. Howard County 911. I have a lady stuck in a building over here. The water's getting higher and higher on her. That's what I tied myself to. Leather and then a chain linked through it, and I was standing on this, and water was just coming over.
Eventually, these big trees floating down, or like a battering ram, busted that block wall out, and it just disintegrated.
So I just held on to the railings, and I have Jody sort of clinging to me.
He took that phone and he broke the glass that was in the top of the door.
Is anyone gonna come get me? Does anybody know I'm here?
And he said, Joni, I want you to hold as tight as you can. Do not let go. And he went through that window in the door, and then he pulled me through.
Water is continuing to rise, and it was approximately up to our chin.
The water, already me standing 9 feet on top of my desk, from the bottom to that, up to my neck, and then having that suction when this, the window finally breaks.
I didn't just save her life, she saved my life as well.
To make severe weather forecasts that are really accurate and timely, you need a ton of information from a bunch of different sources. JPSS, and it's revolutionizing things. We can see all kinds of things we missed before because of the resolution, because of the different channels. So a forecaster has to know, I'm going to have to really jump on this flash flood warning really quick. We already know from the satellite imagery what that river's doing, how much water is in the area, how wet the ground is. That is the kind of information we've never had before, and now we have it.
What we need here in town is a combination of the JPSS satellite, the Homeland Security stream gauges, and my cameras, and have them all connected together to help the community know when this flooding is going to happen, and we can become a better weather-ready nation and be more resilient.
So Ron Peters, I don't know if any of you know him, he is a resident of Ellicott City. He installed his own HD cameras in Ellicott City after the 2016 flood. He had 17 HD cameras pointed at Main Street and the river and the tributaries and all that stuff. We have the entire 2018 flood in HD video, along with some of the rainfall gauges that were just outside of Ellicott City. So I invited Ron to be a keynote speaker in Phoenix at the American Meteorological Society meeting this past January, and he talked about the efforts there. I don't know if you've recently seen this video. This is from Lake Dunlop in New Braunfels, Texas. This is just last week. This is showing a video. I don't know why it's doing that. Oh, bummer. Oh, here we go. Okay. And you'll see that they have too much capacity, and the dam just broke away. So this resulted in 24 hours later, this entire lake being drained. Every resident around that lake, their docks are now way up here with their boats way up here. Their lives have been changed because the impact of all the rain and the infrastructure. They did not inspect, this was a 90-year-old dam. They haven't inspected the dam below water. They said, yeah, we think that it's getting weaker. One of the officials, we didn't anticipate this. We can't have this. You know, residents are really relying on the states and the counties to help protect them, and they have to do that by making their infrastructure stronger. But this is going to happen all over the country. We're having heavier rainstorms. Reservoirs are going to be up to capacity. They were just getting ready, I think it was in 12 or 18 hours, to open another spillway on another part of the lake to ease some of the pressure on this dam, but who knows if that would have helped because it was in a weakened state. So how do we get out in front of our citizens? Information and data is key. We've collected data for many years. Most of the time it remains on spreadsheets. It doesn't get put into maps. Geospatial data can really help decision makers and can really help the public understand their risks and vulnerabilities. And trusted data can save lives and property. This picture was from April. I attended a summit in Denver called After the Flames. After wildfires happen, a whole new set of risks pop up beyond a wildfire. And did you know that when a wildfire burns, it actually changes the chemical composition of the soil? It turns that soil into a waxy substance, which means that flash flood guidance, which normally might be 2 inches to make a flash flood, now goes to 1/2 inch, because you've just made that entire forest area that's burned an impervious surface. Changes the whole dynamic of a flash flood watch and a flash flood warning. So that was a really interesting workshop. So I want to describe, now I want to turn from a data perspective. Talk about science, I want to turn from a data perspective. What's the problem out there, and what's the problem that we've had for decades? We've had isolated data. It's on my system. No, it's on your hard drive. Isn't it we put it in the cloud somewhere. Didn't we put it on over here? So we have all these sources of data. We have complex tools. GIS programs are not easy to use, right? How many use Esri? Do you use Esri here? So Esri is a big GIS company. Great technology, hard to use, you know, unless you are a GIS expert and you live, eat, and breathe it every day. And there's limited interaction. You have screen sharing. You have, GoToMeeting, Skype, Google Hangout, things like that. So essentially, how many of you have heard the term common operating picture? Anybody heard that term before? Common operating picture, or COP, is something that's used in the emergency management world. And it means that it's an operating picture where you can look at the same data at the same time, so everybody's on the same page. The problem with the common operating picture is it isn't common. You can only see what everybody else is seeing when you're sitting in the same room. Because if you go back to your desk and you pull up their common operating picture, you now no longer have any idea what they're looking at. It's only what you're looking at. So weather, energy, state EOCs, federal governments, states, police, bridges, DOT, Fed DOT, they all have common operating pictures. And guess what? They think all their common operating pictures are the best. They're never going to change to somebody else's common operating picture because they invested so much of their own money into their common operating picture. So what you end up with, none of them talk to each other. None of them. You have millions and millions of dollars that are invested in a GIS infrastructure, and you can't share data in real time between them. If you had, it's almost like the problem with 9/11, right? It was the radios, right? Up in New York, nobody could be on the same frequency and understand what people were talking about. Same thing with geospatial data. If you build your own platform and you can't share data out in real time, then all of a sudden you're not on the same map at the same time. So what do I like to call these? Many cylinders of excellence. You have a lot of cylinders of excellence, and there's a lot of money that's been invested in every one of these. Some of them in the hundreds of millions of dollars. And everybody thinks theirs is the best. So we got involved in a federal government program called Small Business Innovation Research. Has anybody heard of that? SBIR? SBIR is a law that Congress passed to say any research agency that has a research budget of over $100 million or more has to put 3.4% of that budget aside for small business innovation. Great program, very competitive. When we submitted our first proposal, they had 640 proposals, they only picked less than 40. This is across the nation for a particular agency looking for innovation. So what we proposed was to create a platform-independent, product-independent, data-agnostic way of accessing and sharing data across platforms. To put people on the same map at the same time, looking at the same data, interacting with it, not like screen sharing, but actually sharing the data. So we've been working with the All Hazards Consortium, which has a whole bunch of stakeholders across the country. They primarily focus right now a lot on the movement of fleet utility vehicles across the nation. So when there are big power outages, you know how you go out of your house and you'll see like Mississippi Power and Light working in your neighborhood? How did those guys get here? So it's all coordinated between utilities where they ask for response and then utilities send their trucks. So GeoCollaborate is what we launched, and now we're helping to move those trucks across state boundaries and then to access state and federal declarations of emergency, transportation waivers, things like that, so trucks can go across state lines and have the information they need right on their phone in a geospatial way so they can start to get across into areas faster. And I'll just make one quick point about Sandy, Hurricane Sandy in 2012. Power restoration in Hurricane Sandy was delayed by 2 days because the utility trucks coming from all 50 states couldn't get through weigh stations and toll booths because the states weren't set up. They're like, you got 100 bucket trucks, $2 a piece. We don't carry cash, man. We're going to help a disaster over in New York City. You're going to have to wait here while we call our supervisor. That supervisor calls the other supervisor who calls the emergency man. Some states put a state trooper at their border and escorted 100 bucket trucks across their state so they could get through and they could pass the weigh stations and all that stuff. It's now being addressed, and one of the ways that we're working on coordinating that area is by using GeoCollaborate so everybody can look at the map, see who's issued what waivers. Oh, okay, go ahead through. Any guess as to how much it cost the power restoration per hour after Hurricane Sandy? Just throw out a number. Per hour.
100,000.
100,000?
Yeah.
What do you think?
More.
More. More. Price is right, right? You go. $20 million an hour. Per hour. Because you had all utilities responding. And who pays that bill? It's the requesting utility. So Con Ed, New York, has to pay that bill. Of course, they then apply for reimbursement, but they may not always get it. So whenever somebody gets in a utility truck, say in Seattle, Washington, and they start that engine, bing, that's when the meter starts. They're paying, you know, whatever their rate is for all these trucks to drive over and then work and then drive back, and they don't stop paying until they turn the engine off when they get back into their yard. $20 million an hour. So I belong to this Sensitive Information Sharing Environment Committee of the All Hazards Consortium. It's called the Fleet Response Working Group. And we're working, as a matter of fact, I'm going to a meeting right after this, starting at 1 o'clock in Crystal City, where we have a lot of utilities and emergency managers that get together, and we're building this trust framework of data sharing so decisions can be made faster. So what are these trusted data layers I'm talking about? Could be county critical infrastructure, weather information, remote sensing, declarations, waivers, drone data, cameras, federal open data sets, municipality data sets. A lot of information, but once you identify those trusted sources, then all of a sudden, you as a decision maker can get on to GeoCollaborate, look at data, and trust it. You don't have to ask any questions about where did this come from. It's trusted. And you know if it's an ORL, Operational Readiness Level 1, you can run with it. If it's an ORL, Operational Readiness Level 4, it's a research data set that might be helpful for you in this situation. Use it with caution, but we want to put it on your radar. And these data sets could come from federal data sets, state data sets, private sector, NGOs, whoever has data to offer. So GeoCollaborate, what it does is it brings together data, it pulls data from the web, and then it can share it out in real time across any device. And so I want to, in just a second here, so this could be in a Forest Service fighting a wildfire. Weather Service data could be pulled in, sent to the Forest Service, field operations here. They could be collecting data. In a command center, everybody could be on the same map at the same time, inquiring, you know, the same information. Everybody has flexibility to put their own data on as well. It's not a closed environment. So people can add their own information also. This is just an example of University of Wisconsin, the Science and Engineering Center. They have these big satellite dishes. They're taking in data from NASA and NOAA. They process it, and then that becomes data input into GeoCollaborate. It can be accessed and shared. So all these people, they might not even know a thing about GIS, but they know how to use the data, or they get trained on the data. So you can use GeoCollaborate for training as well, keeping in contact with people who you might have trained in a session, how to use the data, have exercises, all that sort of stuff, planning sessions. And this is how it works. You have a leader, you have a follower, there's an unlimited number of followers, and you have a dashboard. And the dashboard can be left up on your computer for as long as you want. You could zoom into Prince George's County, you could zoom into certain areas, and that dashboard won't change, but the data on top of it will. So, you know, if you go out there and you do a survey for a new, you know, widening of a road, you come back and say, oh, there's our critical stormwater pipes are right here. We want to put that infrastructure into our dashboard so we know it's there so we don't break it. So we don't keep digging and breaking it. So there's all sorts of ways you can use real-time data sharing for improved situational awareness. This is the way it works. It's an example of NOAA. If they had data and they were the lead and they shared the data into the cloud, these aren't peer-to-peer systems. These are operating in the cloud. Then Pennsylvania, South Carolina, Virginia, they connect to a URL and they turn GeoCollaborate on. They will get the data that NOAA is sharing out. If these guys join late and they turn it on, they'll get all the data. so they won't miss any data or information that's been shared. Consequently, if you have people in the field or other organizations, say there was somebody collecting burn scar soil conditions, or a smoke model, the high resolution rapid refresh smoke model to show where forest fire smoke is moving, and EPA air quality data. If they want to share data into the cloud, then CAL FIRE could grab that data, and it's all on their common operating picture now. So you have trusted sources providing input into a decision-making environment, so they can be all on the same map at the same time. So what I want to do now is kind of show it to you live and how it works. So I'm going to switch Windows over to, I just passed it, over to GeoCollaborate. And if anybody has a tablet, laptop, phone, you can pull this up on your phone too. So if you open up a browser and you go to Dave2, it's right on the screen in the URL, dave2.geocollaborate.com. I'm going to have you, and what should load is this page. You should connect to this page.
Could you repeat that again, Dave 2?
Dave and the number 2, .geocollaborate.com. And then you should come to this landing page. When you come to this landing page, I want you to click Follower. So when you click Follower, a map should load up. Did everybody see the map? Okay. And so now, when you, what I'm going to do here is Dave J. I'm logging in as the leader. And what I want you to do is turn GeoCollaborate on in the upper left-hand corner. So once you turn it on, your map, and it might be helpful to turn your phone sideways, then the map will, be a little bit wider. Now that it's on, I have control of your map. So as I zoom in as a leader, the follower is going to, all your systems are going to follow me. So I'm zooming right down into, I'm just using my iPad, I'm leading it, zooming down into DC. What I want to do is turn on a data layer. And I want to let's turn on all the active Weather Service watches and warnings that are happening around the country. I'll move out to the west a little bit. And you can see now on your phone and on all your devices, the active watches, warnings, and advisories are showing up. This could be any kind of data set that you're thinking about. It could be your critical infrastructure. It could be a new community that you're planning. And you want to have a telecom with somebody else who can't come into the office, but they can sure connect to a URL, even on their phone. If you want to put in some projections for future sea level rise, you can put those in and send it over to the contractor who's doing the design saying, hey, we got these new numbers in from the federal government and FEMA that we have to use, so you got to, take a look at these numbers and all that stuff. So if I want to go in here and add another, and I'll just do one more data set here. I'll get a satellite picture. So I'll turn on a satellite picture. So you should now be getting a satellite image from a satellite 22,300 miles orbiting up in space, and this satellite image is less than 5 minutes old. So now you can see where the rain, where the clouds are, where we have a few high clouds around. There's a really interesting outflow boundary over us, which looks pretty cool from a previous thunderstorm. That's what this is. This is from storms that were up here, and they had strong downdrafts, and those downdrafts spread across, and this is what you see now, the leading edge of sort of those downdrafts. It's not rain or storms or anything, it's just some residual clouds. If I want to go in here and go into drawing, because I want to identify a freehand polygon, I'll fill it with green and make it transparent. And then I want to draw my graphic. I'll just draw it up here. I now drew that polygon that shows up on your device right here. And that can be shared, that's shared in real time across everybody's platform. So what we're talking about is now a new revolutionary way to use technology to put GIS data to work, so to people that don't even understand how to use GIS, but they want to use the data. They want to use the information. So all the things that you're starting to do, like standing up your GIS data as services, that's all GeoCollaborate consumes, right? Consumes those services, so you're taking the right path. Setting up all those services are the thing to do so you can get across your data sets into other environments. You can also change your base map if you want a different base map underneath and all that sort of stuff. But, you know, I'll sort of pause there and see what other, you know, questions you might have, because when you start thinking about planning, the most effective way to plan is to put people on the same map at the same time and to show them real data, real information, so everybody can understand the threats that you're under or any sort of activities. If I went over here and opened up another tab and I went to the same address, Dave 2, and click Dashboard, then what loads up is the status of where the leader is on a dashboard that's static. But what it also shows are the data layers that I've loaded into GeoCollaborate. So if you were having a meeting on planning along a river bed, you know, for possible flooding or a new community, you could have that dashboard focused on that community, and then any data sets that you collect in a GIS format, you can offer those up into the dashboard, then they'll start to pop up on the dashboard there for everybody to see. So it's a new way of making sure people can connect, and the only thing they need is a URL. So we're just standing up. As a matter of fact, the meeting I'm going to this afternoon, we got a contract with DHS in DC to work with them on their National Infrastructure Coordination Center for how they might want to put GeoCollaborate to work in a shared data sharing environment. We also are working now with WMATA in DC, the Metro folks. They just acquired 4 licenses of GeoCollaborate to use for emergency response. So they're now using it and, you know, getting up to speed on how to use it. Yes.
Yeah. So you're talking about the flooding and everything. So I live in Ellicott City, but not near Main Street. It's like suburban part that I can relate to that the concerns that people were having. So in our planning efforts then, should we be looking more closely at elevation levels, like, you know, topographic data? I mean, I know that goes into the development review process, but you know, like you could have on there, you could have elevations.
Yes.
And you could see where the high points are, where the low points are, and should we be using that more? Should we be looking at it more in terms of, you know, planning?
Absolutely, absolutely. And your GIS team is a critical team, you know, and getting the data together so you can help make those decisions. So you know, the GIS data is one thing, and then what are some of the projections that impact the design that you're working on? You know, if you're designing a park along a river, well, what kind of structures are you going to put in that park if that park floods? You know, you may want to put them back farther, or not put them in, or make them, you know, really resilient to water or you know, moving currents, things like that. So you really have to plan with the worst case scenario in mind. And that worst case scenario is that sea levels are going to rise faster than anticipated, and we've seen it be revised at least 5 different times in the last 10 years, upwards. Rain showers are going to be heavier, so we're going to see more localized flooding. And how do you prepare those communities that you're building to respond? Yeah.
Is FEMA updating their flood maps and with this in mind? Because I know that for our zoning lot area, we use the FEMA, we subtract that area from the total zoning area, if I'm correct. I think I'm correct about that. You know, maybe we need to be rethinking that a little bit.
Yes, I think you're right. I think you hit the nail on the head. FEMA is going through updated flood maps, but they work at, you know, a certain speed. They're doing it very much so in disaster areas as a response, so they can sort of try to guide flood insurance and things like that in the future, and building codes. I was invited several years ago now to speak, it was after Sandy, to speak at the International Code Council meeting. It was in Atlantic City. They asked me to be their lunch speaker. 4,000 people. And like 3 16-foot screens. And I took them on a tour of the world to show them the impacts that climate change is having. And they came out of that. I must have had, out of those 4,000 people, there were about 100 to 150 from counties all around the country wanting to learn more about this and impacts. Yes?
So I'm also, so one, I've just been doing so much research in the town of North Brentwood, which is why I just have a lot of references from there currently. But what are, or have you seen how communities are dealing with like their pumping stations as it relates to like climate change, resilience? And I bring that up because, so we have a lot of communities along the river. There are pumping stations there now, but like I was told that the pumping stations don't necessarily, like whenever the pumping stations don't operate on like a generator. And so if there was like a major event and the pumping stations went down, then these communities that are already like really susceptible to flooding would probably like actually flood at the levels of which they were flooding at, which is where we had like hundreds of people being evacuated at a time.
Sure.
So I mean, like, how are communities just dealing with their infrastructure, and then how might we even be able to use mapping to better determine like where we're going to invest public dollars for infrastructure improvements or enhancements?
That's right. No, that's a terrific question. And the folks after Hurricane Florence in North Carolina were going through exactly that. There were some communities that were pretty new that had, I think, a pumping station that didn't work because they had major power outages, and water went up to the first floor in all those communities. And I have pictures of them rescuing people from second floor windows in these communities of relatively new homes. And so you know what's going to happen. I mean, you know, it would probably be very beneficial in this office to start to think about areas that are vulnerable to flooding in Prince George's County. And then to say, a flood is coming, it's happening, what are the impacts, and how can we help our communities understand that ahead of time? Because then they're not going to turn around and start saying, nobody was there to help us. You know? Yes?
So mine's more of a technical question from the IT side of things.
Sure.
Do you see this as more of a planning tool? GeoCollaborate I'm talking about. So for looking into the future with the data, people collaborating now and saying, what if, not what if, but this is going to happen, so you know, what do we do? And we're going to use this data to help us decide that? Or do you see it, it sounds like that to me, but do you also see it as a tool for during a disaster? And if that's the case, how do you make sure that's available to everybody who needs to have it in a very serious disaster where there's loss of power and loss of cell towers and loss of whatever?
Sure, that's a great question. And so with GeoCollaborate, it's not really an either or. It's a new enough technology now where people are starting to think about, wow, how can data access and sharing help me in my job? So we're talking to people about training, using it in training. We're talking about using it in planning, because the data sets that you can get now from trusted sources can now be accessible faster. And we're trying to eliminate the technology burden that everybody has, right?
The kind of like goes back to the old kind of ring up telephone. I say that to people sometimes because nobody cared how that telephone worked.
That's right.
They just knew they could pick it up and use it.
And they'd get an operator.
Right.
Exactly. So I can't tell you how many people I've shown things to just by clicking a button or two, turning them on, zooming into their area. They're like, wow, what is this? And their GIS or technical person standing next to them say, well, that's a project we've been working on for the last 10 years, getting all this data ready to do this. We just never had a technology to share it out and connect disparate platforms. So it could be any use case that you think about. And for major disasters where there's a lot of power out and all that sort of stuff, it will be impacted, right? I mean, this works in the cloud, so most likely it's going to be operating. You just need to get to it, right? So if you can transport yourself out of that damage area, you can still coordinate things because you're controlling things in the cloud. And so that's where it's been very, very beneficial.
Can I follow up?
Sure.
For a comment. How well does it perform with extremely large data sets? Because I was involved with a group with the USGS that was mapping the entire Chesapeake Bay. Excuse me, I can't remember the term now. Watershed, I'm sorry.
Okay, sure.
And it's all at 1 meter resolution. So
Right.
it's super high.
The LiDAR data?
Yeah. No, land cover.
Land cover, okay,
Yeah.
Landsat stuff, so.
Which, might be important in determining
Sure.
runoff and
Sure.
vegetated areas and things like that.
That's a great question too. So if you have a really large data set, there's a way to optimize the data set itself. So instead of sharing like a GeoTIFF image, you're sharing WebMap tiles, right? And so WebMap tiles are designed so they're not really impacting your bandwidth a lot, and you're only making a data request for the domain that you're zoomed into. Right? So if you zoom all the way out to look at the entire Chesapeake Bay, you don't need 1 meter resolution. So you're only getting the resolution that you need to see. But the closer you go in, the WebMap tile gets higher resolution. And so you're really optimizing the use of the bandwidth so you can get that information to people and put it to work. So we've seen a lot of success in that area. Yes?
This is an amazing tool.
Oh,
This is
thank
really
you.
wonderful. I was just in St. Augustine at a climate change conference for 3 days, and this is just like the whole next step that we have to get to. But I just want to ask you a little bit about sort of your business model. You said that this is going to be, you're selling, there's licenses involved?
There are licenses, yes.
And you said like Formata got 4 licenses. What's a license good for?
So,
and
sure.
Is it an annual license or?
Sure, that's a great question. So what we ended up doing through lots of experience and testing, like Pennsylvania Emergency Management Agency has it, WMATA, now DHS, NOAA, it's bundled in 4 licenses. So what does that mean? It means that you can have different instances, like this one's Dave 2. I could have Dave 3, Dave 4, Dave 5, .geocollaborate.com. You could have, let's say PG1, PG2 or PG planning 1, 2, 3, 4. That's $75K to set everything up in the cloud, train you, have some professional service hours where we would come in and work with you. And then each year after that, it's $40K for the cloud services and for the upgrades and stuff like that. So you get maintenance and, you might say, hey, we'd love it to do this. We can build that in and expand the capabilities. Now, one of the things that we're doing because we're now, because we successfully went through the SBIR program within the federal government over the last 6 years, we are now sole source with every federal agency in the U.S. government. So that SBIR program is very advantageous if you survive getting through it. So what that means is, for example, we're about to get a task order with a NOAA division. We'll be doing some improvements to GeoCollaborate to get access to more of their data. That might be a $50,000 upgrade in technology. We give that to all of our users. So you might be paying $40K a year to maintain it, but you might be getting a $50K upgrade in the technology because it was paid for by the federal government. So we try to really leverage those federal dollars across federal agencies, state agencies, and counties, so they can see some benefit. So it's really just really about getting the data sharing and collaborative capability going to put this process into your mind, because it's so important in your planning that you consider these changes, because they might come so fast that 10 years from now, you're still going to be here working and you're going to say, why didn't we plan for that? And I'm trying to help that, by saying we are going to see heavier rain showers. We're going to see more floods. We're going to see more intense storms. So we have to work together to build more resilient communities.
Yeah, one of the saddest stories I've heard is that if the levee work that they did all around New Orleans after Katrina, they spent $4 billion on it, and it's going to be outdated in 4 years.
Yes. Yeah, and it's only for Cat 3.
Yeah, it's that too. It's amazing.
Yeah, Army Corps they charge a lot of money.
So those licenses bundled in for $75K.
Yes.
40 each year to follow.
Yes.
And you said you could have like day 1, day 2. So
yes.
Was my instance here one of those
yes.
licenses?
Yes.
So 4 people basically, or 4 devices.
I would not 4 devices, because you get an unlimited number of followers.
Oh, okay.
So you could have the entire county. You could be briefing the governor from here if you wanted to.
Got it.
So think of an instance as a use case.
Yes.
Right?
Yeah.
So you would have one maybe for planning, one for response, one for training, one for exercises, things like that.
And that includes whatever data people share out there? Like
Yes.
You can look at whatever is there that anybody else has shared?
Yes. Yes, and so what it really does is it sets you up to start thinking about these data services, right? So open data, open federal government data, they have a lot of data available. DC, has their GIS data. Prince George's can.
All of our PG Atlas layers are available as services.
Your Atlas as services, so we would test those. And if we have problems with accessing them, we'll come and work with you and we'll say, hey, we're having an issue with this. Can you take a look at how you're setting this up? Or maybe it's this switch you need to, and so once you get up to speed with that, you'll have so many ideas for how you can put it to work to help the community, to help your own planning processes, to help your own communication. Like you could turn one instance into a public facing and embed this in your website. So you could have somebody to just share critical data sets during certain events, and it'll be on your public facing website that people can just turn on and off layers themselves very simply.
I'm sorry about dominating that, but can't you do a lot of this in ArcGIS online anyway?
You can, but you don't need to be an ArcGIS user for this.
Okay.
Right? So one of the guys that I've partnered with who are working on some different things, he used to be the public safety manager for Esri, for all of Esri. And he said, Dave, I don't know if you know this or not, but what GeoCollaborate does is it eliminates all the requests for passwords and setting up all that stuff, that really bogs down Esri systems. So yes, you can't do the real-time data sharing as in moving people's maps around with Esri. They don't do that. I've met with them for half a day with Jack Dangerman about doing this. But what they do in sharing information takes a lot more work to set it up for sharing with the passwords and the username licenses and all that sort of stuff that you have to, you have to have a license to look at something that I'm going to make for you. And what we do is we can leverage any GIS system. So OpenStreetMaps, anybody putting up their own data KMLs, we can take CSV files, and share those out in real time. It's all about speed, and it's all about, not ticking people off because they have to enter usernames and passwords for every data set they want to look at. But you can still set the passwords, right? So if you have a special data set you want to share just for employees here or something, you can assign a password to it, and then if you share it out, they will be asked for their password. Yeah.
Well, it's about that time.
Wow, look at that. Wow,
I
that was
want
quick.
to say thank you very much,
Thank you.
Dave.
Thank you.